In today's class, we are going to derive the three equations of motion. But before moving to the equations, let's discuss some basic terms related to motion. Like, what do you mean by motion? What is velocity and what is acceleration? The answers to all of these questions will be given by this smiley. Yes, I am not joking. See here, initially when I am holding this smiley, it is at rest. But when I am going to drop it on the ground, it has traveled a certain distance in the downward direction. So now we will say that the ball is in motion. So what is motion? Anything which is not at rest or when an object has covered a certain distance, we will say that the object is in motion. Next question is, what do you mean by velocity? See here, initially the body was at rest, but as it traveled downward, it has gained some speed. So velocity is nothing but speed with a direction. So the unit of the velocity will be meter per second. Now in the motion, we use the term u to denote initial velocity and the v to denote final velocity. When the ball was in my hand, it was at rest, so its initial velocity was 0. But as it travelled a downward movement, it has gained a certain velocity in the course of the motion. So by the time it will reach the ground, it has gained a certain velocity. V is used to denote that final velocity that we obtained at the end of the motion. Next term is t. T is used to denote the time taken for our motion. Next is, what do you mean by acceleration? As I said, initially the ball was at rest, but during the course of the downward motion, it has gained a certain velocity. This rate of change of velocity is known as acceleration. So acceleration is basically v minus u upon t. Now there are two types of acceleration. It can be either uniform acceleration or non-uniform acceleration. The acceleration of the freely falling bodies, like the ball as I dropped, was uniform acceleration, as the rate of change of velocity with the time is constant. But consider a car moving on a road and it keep on changing its speed in different interval of time. For example, in the starting first hour, the car was traveling with a speed of 40 km per hour. But for the second hour, it has gained a speed of 50 km per hour. So at different interval of time, its speed was different. So this was an example of non-uniform acceleration. So till now we are done with motion, velocity and acceleration. Now the next important point is the difference between distance and displacement. Consider a car moving from a point A. It has covered 60 km and reached the point B. Next it covered another 80 km to reach the point C. And after reaching the point C, it has again started moving towards the point B. So in the course of this complete movement, it has covered a distance of 60 plus 80 plus 80. The distance covered will be from A to B, from B to C, and again from C to B. So total distance covered here will be 60 plus 80 plus 80. A total of 220 kilometers has been covered by the car. But when I will talk about displacement, displacement is the shortest distance between the initial and the final position. So this was my initial position and this is my final position. The shortest distance between them is 60 km. So in this case, my displacement will be of 60 kilometers. We will use the symbol S to denote displacement. Next, when we are going to solve the numericals based on the equations of motion, I will use positive and negative for acceleration. So when we are going to denote acceleration with a positive sign and when we are going to denote acceleration with a negative sign. Let's discuss first this. When the acceleration is in the direction of velocity, then the sign of acceleration will be positive. But in certain cases, when acceleration is opposite to the direction of velocity, we will denote it with a negative sign. So till now we have discussed the basic terms related to motion. Now let's move to the derivation of the three equations of motion by VT graph. It is moving with a uniform acceleration, so VT graph will be a straight line. Initial velocity is u, final velocity v, and the time taken for the motion is t. Next, I am going to join the endpoints of the graph with the axis. As you can see, these are parallel lines, so these will be equal. I can write here AD equals to OC equals to T. Next, we can write BC equals to OE equals to V. Next, CD will be equals to AO equals to U. Next important point to note here is the three equations of motions will be applicable only when the body is moving with a uniform acceleration and the body is traveling in a straight line. So our first equation of motion is V equals to U plus AT. Let's begin with the derivation of the first equation of motion. This is my VT graph. I know that the slope of the VT graph gives us the acceleration. The slope of VT graph denotes my acceleration. And how we are going to get the slope? Slope equals to y coordinate upon x. So in this case, when I am going to calculate the slope will give me acceleration. For finding the slope of this graph, slope will be y upon x. The y coordinate here will be BD and the x will be AD. So acceleration will be BD upon AD. Now I can write BD as BC minus CD and write AD as it is. Fine. Next is BC. In the place of BC, I can write V. For the CD, I am going to write U, and for AD, we are going to write T. Now cross multiply. On cross multiplying, it will become AT equals to V minus U. When I am going to shift U from RHS to LHS, the negative sign will convert to positive. So here I get V equals to U plus AT. Okay. Next, this is our first equation of motion. Next, we are going to derive the second equation. The equation of motion is S equals to UT plus half AT square. Now for the derivation of second equation of motion, we know that the area under the VT graph will give me displacement. So to calculate the total displacement, I have to find the area under the VT graph. To find this area This complete area is divided into a rectangle and a triangle. So the area under the VT graph is area of rectangle plus area of triangle. The area of rectangle is given by L multiplied by B, that is length multiplied by breadth. In this case, the length of the rectangle is OC and the breadth of the rectangle is CD plus area of triangle. Area of triangle is given by half base multiplied by height. Base of the triangle is AD and height of our triangle is BD. Now put values in them using the 3. First, I am going to write OC. In the place of OC, I will write T. For CD, we are going to write U plus half. For AD, again, we are going to write T. Next, for the case of BD, as previously we have also calculated, we can write BD as BC minus CD. BD will be BC minus CD and BC is equals to B and CD is equals to U. So our BD is V minus U. So in the place of BD, I am going to write V minus U. Now in the first equation of motion, we have derived V equals to U plus AT. This was our first equation of motion. From this I can write V minus U equals to AT. Now put this value of V minus U here. On putting the value of the V minus U in the equation, I am going to get as equals to UT plus half T multiplied by, in the place of V minus U, I will write AT. So this is nothing but as equals to UT plus half AT square. So we are done with our derivation of second equation of motion. Next, we are going to derive the third equation of motion. Third equation of motion is 2as equals to v square minus u square. So let's begin with the derivation of third equation of motion. So third equation of motion is 2as equals to v square minus u square. Again, we know that area under the VT graph gives us the displacement, but this time I am going to take it as a complete figure. This complete figure is of the shape of a trapezium with two sides parallel and two non-parallel sides, and area of trapezium is given by half sum of parallel sides multiplied by height, or we can say the distance between them. In this case, our parallel sides are OA and BC. So I am going to write as equals to half OA plus, it is sum of parallel sides. Parallel sides are OA and BC. So OA plus BC multiplied by height. Height is OC. Now start filling the values in them. As equals to half OA. In the place of OA, I am going to write U plus BC. BC is V multiplied by OC. OC is T. Now again from the first equation of motion, I can write T as V minus U upon A. Now put this value of T here. From the first equation of motion, I can write T as V minus U upon A, and I am going to put this value of T here. When I am going to write, it will become as equals to half U plus V multiplied by V minus U upon A. We know that A plus B multiplied by A minus B is nothing but A square minus B square. So it will become as equals to half V square minus U square upon A. Cross multiply them and we will obtain 2A as equals to V square minus U square, which is our third equation of motion. In the next video, we will discuss numericals based on these equations of motion. Please like, share and subscribe to the channel.